Well, folks, so a few of you were asking about trigonometry. So this is for junior cert higher level. It also applies there to leaving cert, both higher and ordinary level. What we're going to be looking at is right angle triangles. Now, there's kind of like four things you need to know. First thing, in a right angle triangle is Pythagoras' theorem. I kind of get different coloured pens. Maybe up here. So first thing here is Pythagoras. The smelly old Greek has theorem. Now, the key points when you're using Pythagoras, what they give you is, they give two sides, and they ask you to find third. So say, for example, I had this triangle here. These are all right angle triangles. So all we're doing at junior cert is right angle triangles. And they give you the famous one is the 3, 4, and we'll call it x. Now, what Pythagoras says is the hypotenuse squared. Now, the hypotenuse is opposite the right angle. It's the highest side. The hypotenuse is the highest number of a side. The hypotenuse squared, so in this case x squared, is equal to the sum of the squares of the other two sides. So it's equal to 3 squared plus 4 squared, or 4 squared plus 3 squared. Work that out. X squared is equal to 9 plus 16. X squared is equal to 25. X is the square root of 25. X is 5. Now always think about your answer. Does it look right? Does it fit in? It does. Because it has to be at least bigger than 4. You know, in that one. So it's the highest number. How do I get new slides in that there now? I don't know. So we had another triangle there. Over here, right angle triangle once again. I'll not make it as nice. Random numbers, 10, 8, and I want to work out the height of the building. So once again, when they give you two sides to ask to find that third side, we're going to use Pythagoras. So Pythagoras says the hypotenuse squared. Hypotenuse, which is opposite the right angle, 10 squared, is equal to h squared plus 8 squared, or 8 squared plus h squared. Tidy that up. 100 is equal to h squared plus 8 squared. 8 squared we can work out to be 64. And then just numbers one side, letters the other. Try and keep your squared positive there. So 100 minus 64 is equal to h squared. 36 is equal to h squared. H is the square root of 36. H is equal to 6. Now, they don't always work out to be nice whole numbers, natural numbers, or whatnot. New drawing, there we go. Next thing, we'll do another Pythagoras. We'll do really random numbers here. Drill it into it. Say 5, 3, we'll call that x. Once again, when we're given two sides, asked to find the third side, we're using Pythagoras. So the hypotenuse squared, 5 squared is equal to 3 squared plus x squared. Work out your squared. 25 is equal to 9 plus x squared. Oh, this is working. Oh, that's my 3, 4, 5. We'll change that to an 8. So 8 squared. And 64 is... I can't get away from the 3, 4, 5. Bring that across. 64 minus 9 is equal to x squared. 55 is equal to x squared. To work out x, it's the square root of 55. Now put that in your calculator. See, does it simplify it? Doesn't. So what that answer is known as there, if they ever say leave it in third form, you just write it as square root of 55. If they wanted it to 2 decimal places, the nearest whole number, press your SD button and say it was to 2 decimal places, you might say 7.42. You know, so either or. If they ever say third form, means leave it in your square root. If they say to 2 decimal places, press your SD button. So that's the first thing there we need to know in Pythagoras, or in right angle triangles, is Pythagoras. The second thing that's not Pythagoras, we're going to be using our trig identities. So number 2 is our trig identities. Now it sounds swanky, but this is my sine, cos, and tan. So there, sine, cos, tan, heaps of different rhymes. I like Oliver has a handful of apples. Someone else might say, silly old Harry caught a heron, touring off America, trawling off Africa, whatever you want, or Sokotoa. But I like this one. Oliver has a handful of apples. So this is when they give you a side and an angle, or ask us to work out an angle. So say, for example, here, they give us a right angle triangle, and they say that's 5. This is 35 degrees, and that's x. So we can't use Pythagoras here. Always go through the process. Can I use Pythagoras to work out x? No, because I'm not given two sides. If I'm not using Pythagoras, then straight away I'm writing down OHA. I write down OHA because that'll allow me to determine which of these trig identities it's going to be. So my O stands for opposite. Now I'm standing here at 35 degrees. What's opposite me? It's my x. H stands for the hypotenuse. What's my hypotenuse there? It's 5, and I don't know my A. So I know I'm going to be using, what is O and H? It's sin. So I write down sin. What always goes after? My sin cos or my tan is my angle. So sin 35, and keep the order the same, is equal to O over H, x over 5. Now once we have this then, we're just going to bring whatever's on the bottom, not always the number, whatever's on the bottom comes in front here. So what I've got is 5 sin 35 is equal to x, and then we type that into our calculator. 5 sin 35, press equals, we'll say to 2 decimal places, 2.87. So x. And again, it looks right. It's not more than 5, which it can't be. Now, that could be any version of that. So say if I had another right angle triangle. So again, this all applies to right angle triangles. I'll put the angle in up here. We'll call it 41 degrees. We'll know the hypotenuse, we'll say 7. And we're working out this thing here. So, once again, can I use Pythagoras here to work out x? I can't, because I don't have two sides. If I don't use Pythagoras, straight away, I'm writing down OHA, OH and A. So I'm standing at 41 this time. What's my O? I don't know. What's my H? It's my 7. And A, my adjacent, is the remaining side, which is x. Look at your trig identities. Which one is it? It's not sin, because I don't have my O. It's cos, because it's A and H. So cos 41, keep the order the same, is equal to A over H, x over 7. Now to work out x, just bring across the number on the bottom, or bring across whatever's on the bottom and in front. 7 cos 41 is equal to x. Type that into your calculator. Hope your calculator's not in radians, and you get 5.28. Again, that answer looks nice because it's less than 7. Now we'll show you one there. The only way I can get more difficult is, say we had a triangle like this. Fill in an angle there, say 62 degrees. Working out this, and say that. So, can I use Pythagoras here to work out that side? No. If I don't use Pythagoras, I'm writing down OHA. OHA. Opposite. You're standing at the 62. What's opposite you is 8. What's my hypotenuse? I don't know. And my adjacent is x. So I have my rhymes there in the previous one. Write them out again. Oliver has a handful of apples. Which one is O and A? It's tan. So tan 62 is equal to O over A, which is 8 over x. Now bring across whatever's on the bottom. Not always the number, whatever's on the bottom. So the x goes in front. X tan 62 is equal to 8. Tan 62 is just a number. It's a brute of a number. Put it in your calculator. So if I had like 2x is equal to 8, how do I work out x? I go 8 divided by 2. That's a nice number. Now I've got a brute of a number, a tan 62. So you could type it into your calculator and see what it works out as. Or alternatively, just bring it in below. 8 over tan 62. Now you'll have to close your bracket or you'll get syntax error. So 8 over tan 62, close your bracket, and 2 decimal places says 4.25. So that's the only way that'll get more difficult, is when there's a letter on the bottom. So that's your second of your 4 things. that you'll need during trigonometry. So your first one is Pythagoras, where you give you two sides. Ask to find third. Next one there is your sin, cos, and tan, your trig identities. And when we're working out a side, now we'll use these trig identities to work out the angle. So the third thing there is finding the size of the angle. But it links in there to number 2. So say I have again a right angle triangle. And we'll say this is 1 and this is 2 up there. And they want us to work out this angle here, A. Now, can I use Pythagoras to work out A? No. I can use Pythagoras to work out the length of the side. That's not what they've asked me. They've asked me to work out the size of the angle. So if I'm not using Pythagoras, what am I writing down? I'm writing down my OH and A. Straight away, if you're not using Pythagoras, that's what you're doing. So I'm standing at A. What's opposite me? I don't know. What's my adjacent? There, it's 1. And what's my hypotenuse there? It's 2. So which of these trig identities? Write them out for the third time. Sin, cos, tan. Oliver has a handful of apples. Which one is A and H? It's cos. Now, cos A is equal to A over H, 1 over 2. To get the size of the angle, we're always going to be doing a bit of shifting. So what I mean by that, you press the shift button in your calculator. So the angle is cos inverse of a half. Put that in your calculator. Shift cos of a half and you get 60 degrees. So that's your angle. They could ask you for the third side now. You can work it out using your trig identities, or you could add up your 90 and 60, take it away from 180. Another one of those, say we had this, B, make up anything at all, try not to use cos. We'll see there's 7 and 4. So, to work out the size of that angle B, can I use Pythagoras? Not to work out the size of an angle. I can use it, but it'll give me the length of that side. So I'm not using Pythagoras, I'm writing down OH and A. Where am I standing? Am I standing at B? What's opposite me is 7. What's the hypotenuse? I don't know. Adjacent there is 4. So which one of these? It's tan. So tan B is equal to O over A, which is 7 over 4. To work out the size of angle B, it's tan inverse 7 over 4. Put that in your calculator, shift tan, and you get 60.26 degrees. It's not always around the 60s or anything. Now, if they did ask you for the degrees, minutes, seconds, press under your B button there, and you get 60 degrees, 15 minutes, So if they did ask you for DMS. So that's a third thing. And the last thing you need to know, it's simple. It's the area of a right angle triangle. And what you do there is half the base by the perpendicular height. So I'm insulting you even by telling you this. You just know it. So say there, I'm giving that's 8, that's 6. It's a right angle triangle. To work out the area, half my base by my height. Work that out, make it 24, say whatever, square units. The only way they could maybe mess you up on that, say they give you this, 10, 12, and they ask you for that area. I don't have my perpendicular height. So I'm going to have to use Pythagoras to work out this height here. What Pythagoras says there is 12 squared is equal to h squared plus 10 squared. Tidy it up. 144 is equal to h squared plus 100. Bring that across. 44 is equal to h squared. H is the square root of 44. That's it in third form. Does it simplify down? 2 root 11. Now, to work out the area, it's half the base by the perpendicular height, half 10 by 2 root 11. You put that into your calculator. And you get 10 root 11. Now, look at ones then. Final thing is maybe when they put the two triangles together. So say I had a triangle like this. And there's, we'll call it A, B, C, D. It's a right angle triangle, so that's a right angle as well. There's 53 degrees. This to this is 3 meters, and there's 30 degrees there. And what they've asked you is work out the length of DC, which is this boy down the bottom. Now, what you're going to have to do is split that up into 2 right angle triangles. You always need 2 bits of information to work these things out. So I'm going to work with the triangle ABD. Why else would they give it to you? I don't have enough on the right hand side. I've only got an angle. So there's 53. There's 3. Now there's no point working out AB because that's not a common side to it. So I may as well work out AD because that's common, as you can see with my both triangles. So can I use Pythagoras to work out this side? No. If I'm not using Pythagoras, I'm writing down OH and A. So opposite me is x. Hypotenuse I don't know. Adjacent there is 3. Now my rhyme, my sin, cos and tan, is Oliver has a handful of apples. Which one is it? It's tan. So tan 53 is equal to O, which is x over A. Bring your 3 across. 3 tan 53 is equal to x. Type that into your calculator, and you get 3.98. Now get into the habit, throw that back into the picture. Now they've asked me for DC, so I'm on triangle number 2. There's 30 degrees. DC, you don't know, but that's what you're looking for, so we'll call it X, and there's my 3.98. Again, can I use Pythagoras? No. If I can't use Pythagoras, I'm writing down OH and A. Standing at 30 degrees. Opposite me is 3.98. Hypotenuse, I don't know. Adjacent is X. O and A, tan once again. So tan 30 is equal to O over A, 3.98 over X. To work out X, first thing, whatever's on the bottom comes across. So X tan 30 is equal to 3.98. That's just a number once again. X is 3.98 over tan 30. Put that into your calculator. Close your bracket, remember, and you get 6.89. So that's it. Go back over them. It's a limited toolbox, but you have to keep